Hey guys, welcome back to the channel. Today we'll be solving LeetCode 242 valid anagram. So we're given two strings S and T, and we want to return true if T is an anagram of S. So what is an anagram? An anagram is a word that that has the same amount of each letter as another word. So you're probably wondering, how can you tell if two words are anagrams? And your first intuition may be, why don't we just sort the array? And if we sort the array, we're gonna have every single letter be in the exact same position, and we can just compare them if they're equal and return true. Now, well, this is not a horrible solution. It does have an n log n time complexity, and we can do better. We can actually achieve a linear time complexity using a hash map. We can count the number of letters in each string. So we can have a key for each letter and just count the occurrence of each letter. And this will be more efficient than sorting each string, and it can be done in linear time with constant extra space. So let's get into that. We can solve this by iterating through the first string and checking so we're going to go through every single character, and we're going to add to our dictionary, if it's not already in the dictionary, that character, and add one to it, so one occurrence. And if it's already in there, we're going to increase that by one. So let's do one iteration through the first string. So we start off with A, and we see that dictionary is empty, nothing's in the dictionary, so we're going to add A to our dictionary and increment this by 1, and now our dictionary is at 1, and I'm actually just going to draw this out. Then we go to our next iteration n, and we see that it's not in our dictionary, so we're going to add it, and we've seen one n so far. Then we get here and we see that A is already in our dictionary, so we're going to increment A by 1 and it becomes 2. Then we see that G is not in our dictionary, so we're going to add it, set it to 1. Then we get to R and we see it's not in our dictionary, so we're going to add it to our dictionary. And this becomes 1. Then we encounter A again and we increment it by 1 and it becomes 3. Then last we get to M and we see it's not in our dictionary, and we set this to 1. Now we've completed one iteration to the first string, and now we're gonna loop through our second string, and we're gonna check, is n in our dictionary? If n is not in our dictionary, we're simply going to return false right away, because we know this is not an anagram. How can this be an anagram of this if it doesn't even contain, we're missing a letter from here. But if it does contain the n, and n is not 0, if n was already in here but it was 0, we would also return false because we ran out of that letter. But if it's not 0, we're going to decrease it by 1, and this will become 0. Then we're going to go here and we're going to see is A in our dictionary, and it is. So it becomes 2. Then we get to G and we see is in our dictionary, it is. So it becomes 0. Then we go to A and we decrease it by 1. We get to R and we see if it's in our dictionary, it is. So we decrease it by 1. Then we keep iterating, we get to A and we decrease it again. Then we get to M and we see it's in our dictionary, so we decrease by 1. And we're done 2 iterations, and we're going to have one final iteration where we're just going to simply loop through our dictionary and see if every single um, key value pair for the value is going to be 0. If it's not 0, then we're also going to return false in that case. And if we pass all 3 iterations at the end, we're just going to return true. The time complexity of this algorithm is going to be O of n, because we have to iterate through the string or one of the strings, and they're all going to be of the same length. But if they're not the same length, we can simply just return false right away, because that's an easy check. If they're not the same length, they're not anagrams. And if that check passes, they all have to be the same length. So we just have one variable n, and that's going to be our time complexity. Our space complexity is actually going to be O1 and not O of n, because there is 26 letters in the alphabet, and we're always going to store the same thing. We're going to store the letters in the alphabet, which in the worst case is 26, and we're going to store an integer, which is going to be 26 integers. But this actually will cap out. Even though it may grow with our input, it's going to cap out at 26 letters and 26 integers, which is a single number, and that's a constant. So it will grow, but it will cap out. So technically, it is constant. Okay, let's get. We're going to start off with a simple check to check if the length of both the strings are equal. If they're not equal, we can simply return false right away, because for 2 strings to be an anagram, they have to have equal lengths. Then we're going to initialize our count dictionary, and we're going to loop through every character in the first string, and we're just going to add it to the count dictionary. But since our dictionary is empty, it does not contain the value at this key yet. So we're actually going to have a little edge case. So basically this is going to try to get the value at C, but if it doesn't exist, it's just going to return 0. And then we can just do +1. So this is kind of similar to writing this. It's kind of similar to like writing this, but it's not basically this is going to handle one edge case for us. So if this doesn't exist, it'll just return 0, but this would actually cause an error if it didn't exist, because we can't have null be added to 1. Then we're going to loop through every character in our second string, and if the character that we're currently on is not in count, we can simply return false because we're missing a letter. Or if it is in count, but we've already run out of letters, so if it's 0, so this string has more of a specific letter than this string, then this would evaluate to true. Then we're also going to return false. But after checking everything, we make sure that we have enough of that character and we have that character in count, we're going to decrement it by 1. And that's pretty much the second loop done. And for a final loop, we're going to get the count values. We're going to get the values from the count dictionary, and we're going to make sure none of these equals 0. If they do, we're going to return false, because our yes, if none of these are not equal to 0, so we want them to equal to 0. That means we've used up all of our counts. That means it's an anagram. But if we have more or less, we're going to return false. And after all 3 iterations, we checked everything and we can return true. Looks like it worked, and as you can see, it's pretty efficient. This will run in linear time with constant extra space. Thanks for watching, guys.